Hi, welcome back to Whoops with C++ Session 21. In today's session, we will see the usage of inline function, how to use it, and what are the advantages of inline functions. Okay, so before going to inline functions, just recall what are the advantages of functions. Okay, okay, I have, yeah, functions dot CPP. Okay, just have a look on this program. So what I'm doing here is I have a code like int a equals to b, int a equals to 10 and b equals to 20. So what I'm doing is here I'm performing swap operation. Okay, so a equals to a plus b, b equals to a minus b, a equals to a minus b. This is also one of the method to swap the two variables without using any temporary variable. Okay, so here I have swapped. Now a value will become 20, b value will become 10. So here I have swapped. Okay, this is the first step. So again I am doing swapping. Second time, third time, fourth time. Okay, so how many times? Almost see wherever I'm almost 8 to 9 times I'm using this code. I'm using the same steps because assume that that is my requirement. I have to use the some swap coding for more than some 8 to 10 times or many times I want to use. Okay, so in this case what will happen is here I am not using any functions. Okay, so I am writing this code like this. Okay, if you see there is a very lengthy code it is, and every time you have to write this code separately like this. Okay, so it's increasing like anything, right? Now I will compile this. So we are getting the output a equals to 20, 10, then again swapping, again I am getting, again I am swapping, again I am swapping 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times I'm swapping. Okay, so every time I'm going to do this swap operation, all these three steps I have to write. Okay, so instead of that, these are the repetitive tasks, right? So instead of this, what I can do is this particular thing I can place in the functions and call it. Okay, same code with by using functions. Now now see the code is reduced. Okay, so here the swap function I'm calling, and I'm writing like this. So it is called a reusability. This particular code you need not to write it every time here. Okay, you define it once and inside a function, and you call this function wherever you want. Okay, so now you can see the code. It is you need not to write all those 3 to 4 lines of code. Okay, so it is what the function usage of the functions. So by using functions, what we can do is we can provide the reusability. Okay, so whenever you are designing a code, you have to keep it in mind that you are designing a code which should be reusable. Okay, so now what I'm doing is I am executing this same thing. So again, but the length of the code and readability is also sorry, readability is also increased in our functions. Okay, so what is the advantages of the functions? So what is the pros? Functions provides reusability. Okay, so here in swap function I have only 3 lines of code. Assume that you are performing a function task, or you are writing a function which is having 100 to 200 lines of code. Okay, and you want to use that function maybe some 10 times, 100 times you want to use. In that case what you have to do is 100 times if you are not using that function means 100 times you have to write that code repeatedly, you have to write that code. Okay, so that is um, that is, it's like waste of writing that much code. So reusability is not there. Our main advantage of procedural languages are functions only. That is modularity approach. So we are using modularity means reusability code we have to write. So by using functions, we can provide reusability. Okay, so when we have some advantages, there will be some limitations also. Okay, or cons also. So what is that? So function call overheads. In the previous sessions itself, I have mentioned what will happen when you call a function. So what will happen when I call a function? It will create a separate stack frame for the function. Okay. So for every function, each time you call a function, a separate stack frame will be created. And if ever any local variables are there, sorry, after that, after creating the stack frame, it has to store the return address after executing the function where I have to go back to execute the statement, which executable statement I have to execute. So it has to store that return address. Then if any local variables are declared inside the function, you have to allocate the memory and you have to assign some value. After that, once the operation is done, you have to clear all the local variables from stack frame. You have to remove all the local variables from the stack frame, local variables or pointers, whatever you have created. All the local stuff you have to remove. And if any return value is there, say for example, if your function is non-void return type, so then for every if it is returning anything, that you have to store it in a accumulator, okay, and you have to give it back to the caller of that function, and by collecting the return address going back to the next executable statement. So these are function call overheads. Okay, so for us, the operations are important. These are function call overheads. So whenever you are executing, these are creating separate stack frame, all these things, it's like wasting the CPU time. Okay, these are unproductive work of our CPU. Okay, so it's just creating separate stack frame. See, whenever I am writing some code, what as an end user I will expect is that code should execute very quickly. Okay, but these things will actually slow down your uh, program execution. Okay, so this is the limitation. If you are function definition is having lot of information, lot of the operations you are doing with the inside that function, then this function call overheads are okay. We can neglect those function call overheads if you are really saving lot of executable statements, a lot of text segment size, and you are doing lot of operations inside the function definition. That time you can ignore this function call overheads that is having that effect will be minimal. Okay, now just assume one of the program, say 1 second. Okay, now just observe here. Here I have one macro. Okay, hash define square x, x into x, int square, int x, return x into x. So this is a macro. This is also doing squaring of two numbers, squaring. By using this function also we can do square. Okay, x into x. Okay, but when you observe here, macros are more efficient than function, because here for macros it will be replaced during whatever you have given here, that will be replaced during pre-processing time. But the compiler for the functions, what will happen is whenever you write a functions, as we discussed, that function call overheads will be there. So separate stack frame will be created for this square function, and next what will happen? The in text, return address, next executable statement address, what is that? That has to be stored in the stack frame, and also all these local variables, whatever is there, either it may be argument or the variables you have declared inside the function, All those things has to get memory in the stack frame. And also here you are returning x into x. After performing this operation, you have to store the value of x into x into accumulator. Then you have to clear the stack frame. Again, you have to come back to the next executable statement. Then you have to give the value to the accumulator value to the caller of the function. So these function call overheads is there. But if you observe here, are we really doing any effective work? So only one line of operation, only one line of operation, but there are almost three to four, five to six function call overhead steps are there. So this is not a uh, good programming. Okay, so what we'll say is in such type of scenarios we will use macros, right? So here the function call overheads will be there. So that is the reason what we'll do is we will use macros. Okay, now just let's see how it will work. Now what I will do is I will generate the preprocessor directive. Okay, execution speed will be more for macros. Okay, so because macros are preprocessor directives, means whenever the preprocessor is there, all the macros will be substituted by the preprocessor. Okay, it's not during execution time, it during preprocessing time it will happen. Now see, I am generating the preprocessing code. Okay, can you see here? So this is my you don't have something like a hash define square, that is not there. So here I have used cout square. If you want, you can use this code. I macros functions dot cpp. Okay, you can see here this particular line is there, right? This is not there here. Okay, in this code. Okay, after using namespace std, this code is there. Here it is not there. Now what I'm doing, int square int x return x into x, that is still there because it is not a preprocessor directive. So here what I'm doing, cout square of square 5 plus 6. So 5 plus 6 is replacing with 5 plus 6 into 5 plus 6. Okay, so whatever you are placing here, that will blindly replace it here. Okay, but okay, this is about preprocessor. During preprocessing time only, the score, these macros will be replaced with the definition. So uh, this is something like a function call, and this is like a definition. This macro declaration will be replaced with this definition wherever you are using during during pre-processing time. Okay, now at the same time, whenever you are using the macros, whenever you are using the functions, what will happen is if you see as or what we'll do, yeah, so you can do readlf macros functions dot o. I have generated .o file for this. Sorry, to read the symbol table. Okay. If you see here, there is a function called, we have the square function underscore z6 square I. So this entry will be there because I'm calling that function. So this entry will be there. So this is a normal function. Okay. So it is there. And also you can generate assembly code also. Assembly code is nothing but the code which comes after the code which comes after compilation. Okay. So we have said, yeah, okay. Yeah, macros. Okay. So assembly code for this we are generating. Okay. So that .s file. If you see here, there is a executable statements generated for the function square. Okay, square 6. Okay, and this is the code. These are the executable instructions for your square function. Okay, these many instructions got generated. Right. Okay. Now, s- Okay. Now compile this program and see. Just I'm generating a dot out dot slash a dot out. So for first one it is coming 41, second one it is coming 121. Okay. So what is the code? What is our code? Across functions dot CPP. So here why it is coming 41 here? Why it is coming 41 here? So because it is having it is replaced with 5 plus 6 into 5 plus 6. So what is that? 5 plus 6 into 5 plus 6. It is giving 41. Why it is giving 41? Because you have to use this technique. How it will be evaluated? Word mass. So means B means whatever is there inside the bracket, the operations. Next of uh, division, multiplication. After that addition. Next subtraction. It is BD mass. Okay, so inside the brackets, first operation, first evaluation, next division, next multiplication, next addition, next subtraction. So what will happen is, so here we have addition and multiplication. First 6 5 are 30, that will be evaluated. Next plus 6. So now addition will be done. So 35 plus 6, that is 41. This is what it will happen when you are doing preprocessor directive. Okay, so like this we are getting 41. But when you are using square, what will happen is it will first it will be evaluated 5 plus 6, that is 11. 11 will be evaluated. That evaluated value will be given to the function argument. So that is nothing but 11. 11 into 11, 121. So this is the value we are getting. So 41 and 121. Okay, I think it is clear for you, right? Now, okay. Um, so macros we have seen. Okay, so what is the macros are preprocessor directives. Macros will be substituted during preprocessing time. We have seen by using minus E option, we have seen how the macros are getting substituted. Even hash include, that is also macro. All this macro substitution will be done during pre-processing time. So what is the advantages of macros? There is no function called overhead. So it's like creating a separate stack frame, creating a separate storing the return address, creating separate variables for separate memory for the local variables inside the stack, inside the macros. All these things is not there. No function call overheads for the macros. Then at the same time, we have seen some of the limitations with macros. What is that? Type checking and typecasting is not possible in macros. That is, say instead of a x, I can give whatever I want, I can give. So here, this function is there, right? Instead of 5 plus 6, what I can do, I can put x plus x also here. That will also work. Okay, and I can give anything. I can give either I can give integer value here, either I can give character value or float value or a string. I can give whatever I want, I can give. But what about functions? If it the function is taking integer, you have to pass integer. I cannot send a string values here. Okay, so like that. Okay, so that type checking is there. Okay, type checking and typecasting is not possible in macros. So macros substitution will be done blindly during pre-processing time. If you have um, observed this code plus minus c, so what is happening is I have given a square of 5 plus x. Whatever is there in the macro, that substitution will be done blindly. So you have taken it will be treated 5 plus x is treated as x and x into x. It will be blindly taken. And one more thing is, assume if you have a lengthy code of a macro, you can write multiple lines of macro, right? So if a macro size is length, macro substitution size is lengthy, then that replacement will be hectic. Okay, that is not advised. Okay, it is difficult. That is also again overhead. Okay, some advantages are there, some limitations are there. So when macros are used is if you have a small amount of code replacement, then macros are advised. If you have a lengthy amount of code, so maybe you have a logic of inside the function, maybe you have some 100 lines of code or 200 lines of code. If you have like that, then functions are advised. Okay, so macros is also having some advantages, functions is also having some advantages. Okay, now we have in C++ we have another method called inline functions, which are having both the properties, macros properties as well as function properties. Okay, so we will see what is that. So inline functions are functions whose function call is replaced with function definition. Say if we have a function, how the macros are replaced. Macros call is replaced with the macros definition. In the same way, we can have the function call replaced with function definition. So inline functions are functions whose function call is replaced with function definition during compile time, like macros. But macros replacement will be done during pre-processing time. However, macros are replaced uh, during pre-processing time. In the same way, inline function calls definition function call will be replaced with function definition during compile time. So then how to use this inline function? It's very easy. So you have a normal function, right? Normal function. Before to that, just add this inline keyword. So then it will become inline function. Okay. Now, one thing you have to remember when you have this inline function, okay, you have to give optimization. Okay, so now what I will do is we have the previous function, right? This one, what I will do is um, one second. Okay, okay. So now what I will do is I will compile this code. Okay, this is the code. So what I'm doing is I am trying to generate. So I am giving some optimization. O3 optimization level. Okay, and this is the compiler optimization. You can have the separate video for this optimization. So optimization is compiler optimization, O3 level optimization I'm doing. So that is optimization flag you have to use. Okay, I'm using optimization 3. Now at the same time, I am going to generate data file. Okay, so now we know how to read the data file symbol table. Okay, macro functions dot o. Okay, now you can see there is still an entry for the function. Okay, so because this function, this is a normal function, right? Okay, so since a function call is there, and you can see this function is, it is a function, right? Now what I will do is how I'm using inline functions now. Macros inline.cpp. Same code, but only thing is I have added inline. Now what I will do is I will compile this program without optimization level 3, without giving optimization. Okay, so now read elf. Oh, sorry, I have used the same program. Macros underscore inline functions I have to compile. Okay, now read elf minus s macros inline dot s, sorry, inline dot o. Now you can see, still, even though we have used it as a inline function, still it is treated as a normal function only. So during compile time, this function call is not replaced with the function definition. It is treated like a normal function only. Okay, so that's the reason what we have to do is we have to use optimization during compiling time to do. So previously we have ran the normal function, a normal function with optimization. So since that was not an inline function, there we can see the entry for this square. Okay. Now I am doing optimization level 3 for this macro underscore inline CPP code. Okay. Now we will compile this. Okay. So compiled. Now I am doing readelf minus s macros inline dot o. Now we'll see. Can you see the entry here? Okay. There is no entry for the square. Okay. Without optimization level, you can see the entry. Okay. But in the normal program also, for normal program, either you do optimization level also, but because it is not an inline function, then you can see the entry. Now here it is an inline function. Since I am using optimization, then it is replaced. Okay. So inline functions, it is like a request to the compiler, just replace the function call with the function definition if it is possible, so that we are using the optimization. Okay, we have to use optimization level. Now what I will do is I am going to generate assembly code for this. Okay, we'll see whether it will be treated like a or wait, I will do one thing. I will compile this without optimization and show you the difference. Eh, macro macros underscore inline dot s assembly code. Okay, so here we have a code called square, right? So you can see here square, it is there. Okay, and you can see uh, executable instructions are generated for the square function. Okay, so now it is treated as a like a normal function only. Okay, even though you have given inline, it is treated as a normal function only. Okay, now what I will do is I will compile this program with optimization 3. Now I will open this code. Now I will search for this square. Now see, you cannot see the square code anywhere. This much only code. Okay, so you cannot find the square code. Can you see anywhere? You cannot find it. Okay, only main function is there. So that function call is replaced with function definition. Okay, you can see here 41, and during compile time that function call will be replaced with function definition. 121, you can see this, right? Okay, so function call is replaced with function definition during compile time only, that this will be evaluated, replacement will happen. So, okay, so this is macro substitution. Okay, this is function substitution, inline function substitution. Okay, there is no function called size, sorry, square. Okay, right. Now going back, so this is the syntax. Now What are the things we have observed is inline is just a request to the compiler. It may be ignored in the following cases. And also you have to use the optimization, otherwise it won't work. Okay, it will be treated like a normal function. When the function definition is size is large, say for example, you have written some code of 100 lines or 200 lines, okay, then it is you are just giving a request to the compiler that if possible, just replace the function call with the function definition. But if the function definition size is more, then obviously this replacement won't happen. Okay. Now at the same time, when the function definition contains loops, like if your function is having if else conditions or while loop or do while loop or for loop, any such type of loops are there, then also that function won't be replaced will won't be treated like a inline function. It will be treated like a normal function because it doesn't know how much memory is required, how many times if else while loop you are doing, how many times do while will go, okay, how many times for loops are there, if else conditions. For all these things, it won't be treated like a inline function. The compiler will ignore the inline request. Okay. And third case is when the function definition contains recursive calls. If you have a recursive calls, what you have to do is every time the separate stack frame will be created, separate stack frame. Once you call, one stack frame will be created. Again, inside that function, you are calling the same function again. So that is recursive call. Now again, one more stack frame will be created like that. We don't know how many times we are going to call this function recursively, so a lot of code size will get increased. So that is the reason even for inline functions, so even if the function definition is having recursive calls to the function, then also inline request will be ignored. Okay. And when the function declaration and function call are in different translation units, so maybe different files, translation units means different files, then also this inline will be ignored and it will be treated like a normal function. Okay. So macros, if you have specified any macros, whatever is there in the macro definition, that will be replaced with the macro call. Okay. Whereas function, in case of inline function, so this is a request. If possible, then only that function call will be replaced with the function definition. Okay. So this is about inline. Inline, in the inline means in the same line the code will be, function call will be replaced with function definition or substituted with the function definition. And these are going forward in currently I am taking C++ 99 standard. So in C++ 11, C++ 14, 17, you can say from C++ 11 onwards, you can see lambda functions. Okay. If you have understood inline functions, then understanding lambda functions are easy. Okay. Now, so what is the difference between inline functions and macros? So whatever we have discussed now, we are just recollecting that. So inline functions replacement will be done during compile time. So what about macros? Macros replacement will be done during pre-processing time. So with respect to inline functions, function overloading is possible. Say it is just like a normal function, right? So all the functions you can do, you can write the same function name with the different arguments. Like that, you can write multiple functions. What about macros? If assume that you have defined a macro hash define square of x, and you cannot define another macro with the same name, so that macro overloading is not possible. In inline function, typecasting, type checking will be done. So this is one greatest advantage. What about macros? Typecasting, type checking won't happen. So that is the reason going forward, wherever we are using macros for small replacement, there you can use for inline functions. Okay. Or you can lambda functions in higher, whether in case of C++ 11. Okay. So inline is just a request to the compiler. It can be ignored. As we said, if you have a static variables or recursive calls, I have missed in the this one. Even if you have a static variables, then also inline request will be ignored. Okay. Inline is just a request to the compiler, it can be ignored. So you are requesting, if possible, just replace my function call with the function definition. It might ignored. Okay. So based on the conditions. So macros replacement is must. It cannot be ignored. Okay. Once you have given the macro means that will be replaced. Okay, that is must. And this is macros are pre-processing time and inline functions will be done during compile time. Okay, now there are small assignments think and do. So what are the advantages of functions over macros? Okay, so when it will be your advantage, the think. Okay, what are the advantages of macros over functions? Okay, functions over macros and macros over functions, and what is the use of inline functions, and also will inline functions increase the performance? Okay, just think I have given I have answered for all these questions in different slides. Just recollect, listen the video once again, you will answer these questions. Okay, so what happens when we make recursive functions as inline functions? So if I write a recursive calls inside inline function, what will happen? So these are some of the important questions and important interview questions also. Okay. Okay, thank you. Thanks for watching.